I think like we are live now. So, Assalamu alaikum everyone. Sorry for being late. So we had a technical problem. So welcome to this insightful webinar on cybersecurity challenges and best practices in HPC environments, which is part of Morocco HPC initiatives. So before we begin, let me introduce our distinguished speaker, Dr. Hanan Al-Mazzi, which is an assistant professor at the College of Information Technology and faculty fellow at the Center of Excellence in Teaching and Learning at United Arab Emirates University. So Dr. Hanan previously worked as a postdoctoral fellow at the Center of Cyber Physical Systems at Khalifa University of Science and Technology from 2019 to 2022. She earned her PhD in computer science and network from Moulay Ismail University, Morocco in 2018, and has since made significant contributions to different fields like IoT, routing protocols, edge computing, cybersecurity, risk management, and so on. Uh, she is also an active reviewer for leading scientific journals and serves as a technical program committee member for various international conferences. So regarding the today's session, Dr. Al-Mazzi will share with us her experience on cybersecurity challenges and best practices in HPC environments. So this session will mainly cover the key risks and vulnerabilities in HPC environments, the best practices for securing systems and data, including zero trust architecture, encryption, and AI-driven defenses, and lastly, the real-world case studies on effective cybersecurity implementations in HPC. So I'm sure that it will be an excellent opportunity to gain valuable insights into securing HPC environments topic. So please ask questions and engage in discussions. So Dr. Lemezzi, we are honored to have you today with us. So without further ado, the floor is yours.
Okay, thank you so much, Imad, for this nice introduction. So I think I divided like a little bit from the purpose of the slides. So with the main focus on information, because I found that information is more critical. So yes, so we will start this webinar by introducing the concept of HPC. So as everyone knows, HPC it's used in order to do some like parallel processing, especially for complex computation applications, and also it is like an optimal way in order to process like a huge amount of information, especially once we are developing some AI technologies and AI solutions and so on. So traditional HPC rely more on hardware. It was like hardware centric, that where we have like a set of users, we have clusters, we have nodes, and so on. But with the advance of the technology or the integration of cloud, now we shift from the hardware centric HPC to the cloud based, where we can have like more storage and more like processing capabilities, and also like an interactive environment. And through the cloud, you can create some interactive environment, not only within a specific workplace, but also like from different places. So integrating a cloud provided like as I mentioned, like a big storage. This is the first thing. In addition to that, it's less expensive than the hardware, especially in terms of implementation and also in terms of maintenance. And also it can provide a lot of services. Instead of like going and working in a specific cluster or hardware, a specific hardware which will be limited, and also it needs like a huge time. You have to wait for us like a queue in order to have access to run your simulation and so on. But using this cloud, it provided like more flexibility, and most of the companies now they are thinking of to integrate this solution, rather than just relying on the hardware side. So yes, HPC can be used for any type of application. So since we use it to run some, as I mentioned, simulations, codes, develop some new solutions, and so on. So any type of application or any type of information can be run on this type of computers. Why? For the simple reason, because especially recently, and once we are like talking about LLM, which is like a language natural processing, about AI solutions, about like machine learning, deep learning, and so on. So most of those technologies, they are relying on information. So if it is processed in a limited data, so it will not like give you accurate results. So means that you have to collect more data. The data size is very huge, and then it need like a strong processing power or strong devices to process this information. So HPC, it's the best solution. In addition, it is the most used one, and especially in research centers, organizations, and so on. So yeah, we can know, you can see the benefit of this type of computer, but in addition to that, there is other like related risk. Okay, so the risk can be related to the infrastructure itself, which is the HPC. It can be related to information, and also it can be related to the user itself. Okay, so later on we will see like the main threats related to HPC from different perspectives. But before that, I found like a cloud security alliance, which is like a sort of working group that they did like a set of studies in order to produce like best practices and guidelines to help users and also organizations to protect their information. So most of the sectors that they are using in HPC, they are like private organizations, in comparison with the public one, for the simple reason, because they can invest more in this kind of solutions, compared to the public one. Also, according to this report, the majority of HPCs, they are focused on Asian countries compared to other countries, and you can see some limited number of HPCs in like, let's see, for example, in GCC countries or European countries compared to the Asian one. So also they ask الemployees and the workers. So I cannot see clearly the slide. Sorry. So during this report, so they try to ask users or the employees about certain cyber threats. So for example, if they are like very concerned or like they are sure that their organization or HPC that they are using is protected 100% and so on. But as a result, they found that 67% of employees that they are using in HPC, they are really concerned about the security or the threats related to the use of the HPC. So where like 71% of them, they mentioned that they have some sort of security controls integrated, but it's not like 100%, which is like if you compare it to the real life, it's something normal. In general, in security, we cannot like secure 100%. Why? For the simple reason, since we are connected to internet, since we have human and involved in the use of this kind of technologies, the rate of the errors, it's very high. Human can make mistakes. In addition to that, we can have some attacks coming from the networks. Maybe, for example, by mistake, we can do some misconfiguration and so on. So the concept of security, it's not all the time that something coming from far, someone attack the network, because this is like once we are talking about cybersecurity, we get in mind that automatically we have an attacker or hacker and so on. But security, it's more than this. So sometimes the problem can be created, as I mentioned, just through error, by mistake, or there is like a misconfiguration. Or maybe it's like a simple user of HPC just instead of like running the simulation in its own node, for example, try to navigate to other folders and did other things and so on. So here securing 100%, it's like somehow ideally achievement that we can reach, but achieving like a highest number like 99% or 90%, it's acceptable level. So yes. So also they ask in this report, they ask about integration of cloud, because till now not all the organizations, they shift to the HPC cloud, Why? Because they have their own hardware HPCs, and they use it perfectly, and it will solve all their local problems. So they don't see like a need to go to the cloud unless if, for example, they need like more storage, as I mentioned, or like more processing capabilities and so on. So then they can shift to this kind of cloud. So according to this report, so they ask that what are the type of services that, for example, HPC cloud can provide in comparison to the hardware one. So in cloud base, it can give you like a full infrastructure, like as a server. You don't need to implement something or integrate or do the maintenance. It's also it's provided through the cloud. It can give you even a full platforms or softwares that you can run through the cloud without, like, as I mentioned, going through the physical hardware. So the most common cloud that is used, it's the private one, okay, equally to the public one. So most of the organization, they prefer these two types, and whether to go with the shared one, public, or they create their own cloud. So this is somehow a report. Why did this report? Because before proposing any practices, or for example before implementing any controls or securing an organization or hardware and so on, so we have to consider other parameters, like including what are the issues that the user can face, what are the problems that the organization can face in terms of information, in terms of hardware, what are their preferences, and so on. Gathering all this information will give us like a general idea about what are the best practices that we can use, and what are, for example, the policies that we can develop in order to secure this kind of platform. So here, once we are talking about security, it's not only the technical part. We are not just talking about the firewall, antivirus, like IDS and so on. This is the technical part. But we have other part which is non-technical, which is related to regulations, policies, laws, guidelines, and so on, recommendations, and so on. So the non-technical one, this should be based on a set of information that is gathered from the organization, or maybe in general, users of a specific platform. In our case, it's the HPC. Okay. So here, the HPC, as I mentioned, as any platform, they have also their own problems. So this is the most common one. So we have, I try to classify them into 3 categories because this is the most common one. So first, we have problem related to the information, like having unauthorized access, or, for example, information corruption, falsification, maybe misuse of the information, maybe we have violation of privacy, and so on. So information itself, it's a main parameter in the HPC, and it should be protected, and also it should not be misused. So we have then the system exploitation, how we are using an HPC. Sometimes it can be overused, like having like some DDoS attacks in order to make some interruptions, or maybe, for example, we can integrate some malicious scripts or softwares and run it into HPC and so on. So from the system side, also it needs like a high protection in order to avoid this kind of threats that can affect the overall HPC operations. So then the third category, it's related to the user, but specifically the insiders. Okay, so insiders here, in general, like people, they are defining insiders as automatically employees, but it can be anyone who can access to the HPC, and any user, employees, maybe students, in terms of academic institutions. Anyone who can access to this HPC is considered as an insider. They have like a sort of credential information or authorization to access to this HPC. So this type of threats, so here, since I have access, so I can inject some malicious files, some malicious folders. So I can also, for example, let's say, for example, collect information from the other users, share like malicious script to the other nodes, and so on, and spread, for example, malicious information, and so on. I can also implement some ransomware attacks, which is like collecting information of some specific user encrypt it and ask for money to provide the decryption key, and so on. So generally, in order to protect HPC, we have to protect the overall environment, as I mentioned, including the information, the system, and also the users. Okay. So here, this is like the most common threats that target HPC. So the first one, we have credential thefts, as I mentioned, like here, it can be done by attackers. Yani someone can get your privilege to laptop privilege and access to your HPC using your credential information. Maybe by mistake you note it in a specific place and someone else get your credential information. Maybe you share it with your colleagues because you trust it, so you trust him or you trust her. So you share your credential information. Maybe they misuse your account. So that's why this is the way how the credential information can be stolen. So why I'm specifying the different type of how the credential information can get stolen, because as I mentioned, like every time when we are explaining the security, we get in mind this is automatically a hacker or attacker, but this is not the case. And sometimes it can be you, the threat, because you share it with someone that you trust. Okay, so that's why once you are operating some confidential information or doing some operation, especially in the workplace, you have to be aware about this kind of behavior, and you have to protect your own information. So we can have also some malware. Like, let's see, for example, I'm developing like a solution. I went to a specific platform, like the most common one, it's like GitHub or Kaggle, and to collect some code. So maybe in that code, there is some malicious code, okay? For me, because I found it will solve my problem or provide me some specific results. I just took it and ran it in the HPC. Okay, so once I run it, it will spread that malicious software and it will affect the HPC. So that's why, and sometimes once we are using some existing or open source codes or software, so we have at least to be aware about if they are trustworthy or not. So then we have the ransomware. I already explained it. So this is when someone can collect your information and ask you for encrypt it and ask you for money to provide you the key to decrypt the information. Okay, so here usually, and as I mentioned, whether someone through your credential information, access to your information and collect it and so on, or it can be insider, and someone who is working in HPC or maybe administrator. It's not the case because they are following some policies, but let's see, the administrator is a malicious one, so they can do the same process. So that's why we will see later on for each type what are the controls or the mitigation strategy that we have to follow to protect us from this kind of threats. So then we have the cryptojacking. Okay, so this is the same as the malware. So this is where we can, for example, like use the cryptocurrency to exploit the HPC resources in order, for example, to like develop some cryptocurrency solutions or do some specific transactions and so on, through exploiting the resource of the HPC. So we have the supply chain. So this is where we can also insert some malicious code into the HPC as a software or as a firmware. Okay, when we were like developing the code or when we are doing some updates, for example, to the HPC. So in case the attack happens, so what will be the main consequences on the user itself and also the HPC? So first, for example, the first thing that, the first consequences is the loss of the information. This information generally, since we process it in HPC, it's the information that we needed to get some results. Maybe this is a research purpose, maybe like to make some decision and so on. It's somehow like a sensitive information. And if this kind of attack happen, it can lead to losing this kind of confidential information. Then we can have some loss in terms of financial loss. Okay, so especially as I mentioned, in case of the ransomware, when someone asks you to provide money in order to give you like the key to decrypt. Okay, or maybe, for example, you are developing a solution for a specific company and you have to deliver your own solution like by a specific time, otherwise you will lose the whole collaboration. So this is also a sort of loss of financial or loss of money. So let's say, for example, let's say like a student who is like trying to develop some research to publish an article, and they need to defend their thesis and so on, and at the end they lost this information, yani the whole simulation and so on. So basically they will develop a lot of a psychological problem like anxiety or, for example, depression and so on. Why? Because rebuilding everything from scratch, it's hard. If you didn't protect your information from the beginning, and if it gets lost, so it can lead to this kind of consequences, especially when it happens in a critical period where you need this information. So then it can lead to loss of trust and reputation. So let's say, for example, if I already use the HPC and my information gets lost, and the HPC administrator or the organization didn't protect my information, so the basic thing that I will do, I will never go with that HPC, regardless, whatever the benefit that I will get from it. Since I was not protected from the first time, I will not go through that. So this means that for me as a user, I already lost the trust to use the hardware itself. And also, since the organization or the HPC administrators, they couldn't, for example, solve the issue, if they can solve it, so then I will not trust them anymore, and this will decrease their reputation. So here, HPC, we are not talking about like local administrator, because sometimes we are like we can get the maintenance also from the HPC providers, and for the companies that they are providing this kind of hardware. So, for example, if they couldn't solve the problem, so for sure the other organization, they will not collaborate with them later on, because it should be like a part of the agreement between the HPC provider and also the organization that they are using this HPC. So in case you get attacked or you feel like there is something malicious, okay, what are the immediate actions? So we'll see later on others, but this is like the first thing that you have to do. So the first thing, or the basic one, obvious one, it's to change your password. So you have to change your credential information, including your password, because maybe the problem it's coming from your credential information. So you have to change it. Then right away, you have to inform the company's cybersecurity teams or HPC administrator if there is any incident that is already happening. Also, you have to isolate your devices, including your laptop, or maybe, for example, you are running a specific simulation, so you have to stop it. Or, for example, you interrupt communication between your local computer and the HPC to didn't spread this malicious or infect other related laptops and so on. Then you have to notify people around you, your colleagues or your friends and so on, that this is what happened, and they have to be aware about these incidents, and maybe they can take also their own precautions. So in general, for malware and ransomware, so we have like a specific mitigation strategies that we can follow in order to protect ourselves from this kind of attacks. So the first, we have to use the network segmentation. So means that we have like, since in the HPC we have different clusters. So the best choice will be like to run like every cluster in different networks. Why? By doing this, or we can call it also like separation of duties strategy, means like by separating, for example, the clusters. Okay, so if one of the clusters gets affected, it will not affect the others. Okay, so this is what we mean by network segmentation. That for every segment we have a specific network, or like a small network of nodes. Okay, that they are running independently from the others. Okay. Or sometimes what we are doing, like, for example, we can, for a specific project, we can allocate a node that all the users within the same project can use only that node. So we will not provide for each team member a different node. All of them, they will work as a one project. So sometimes we have also to keep updating our software, okay, to see, for example, if they are expired or not, or, for example, there is any extra features that we can add or purchase and so on. And the main thing, so we have to have an offline backup. Okay, especially for example, once, as I mentioned, example of the students, for example, all the time, and this is happening, I can also get it from my students. Sometimes they don't have a copy of their project. So once they run it, or for example, something happened to the laptop, it's gone. They have to do everything from scratch. So for the research, it should not be you should have a backup for everything that you are doing. Why? Because malicious things happen. Maybe something can happen to the hardware itself, and so on. So all the time, you have to have your own backups to protect your information. So for crypto jacket, so we have to monitor if there is any unusual behavior or misbehavior or any maliciousness within whether our network or within, for example, navigation. So we can track, for example, the log files, the navigation history of the users. For example, we can use some intrusion detection systems or network traffic detections in order to see if we have any maliciousness within the network or within the files and so on. So for the supply chain, we can use some code integrity checks or digital signatures. So in order to verify the softwares and the hardware that we are using. So we can also follow the same thing as the malware. So we can make some updates. And in addition to that, we have to rely on doing some security audits. The time on time, we have to keep tracking if there is any change within our HPC operations, or if there is like a new added users that they are not authorized, or any maliciousness should be detected through this auditing. So as I mentioned, the main part of this HPC, it's the information itself. We have hardware parts that need to be protected, from the network side, from the infrastructure side, and also from server provided side. But also the main part, it's the information, the user who is using the HPC and integrating some information to be processed. So here, what we have to keep in mind that, for example, once we are running our information, in some cases, I will focus here on research purposes. So we cannot, like, for example, get any information and inject it to HPC and run it, just to get some results and so on. The information should be processed before. Before using the HPC, we have to process this information. And this processing, we have two types, okay? So we have processing in terms of like removing like empty cells in a data sets, or for example, if there is any incomplete information, or for example, we can minimize the information and so on. And there is another classification related to the type of the information that we would like to process. Okay, so let's say, for example, I would like to develop like an AI solution that will classify or provide me the distribution of a specific disease in a specific area. Okay, so my interest, it's on the disease itself. What are the type of disease that we can have, or the health status in general. Okay, but in addition to that, in my data set, I have other additional information, which are the information of the users or the patients. We have, for example, their age. We have, for example, maybe their zip code, their birthday, gender, and so on, and other additional information. So in terms of if we share the whole information and someone steal this information, it can lead to violation of privacy. Okay, and this is another problem, which is like far and close to the HPC. Okay, so far because it's mostly focusing on the information, but it's close because if you violate the privacy, it will affect also your use of HPC. Why? Because we will see later on that we have to apply some regulations that can also protect the information that can be run on the HPC. Okay, not anything will be run in the HPC just because it's available and or it provides us like a extra storage and so on. So what we have to do? Okay, so the first thing, information can be classified into direct identifier, cozy identifier, and sensitive information. Okay, so the direct identifier, it's any information that can identify you as a user, okay, in a specific data set. Okay, like the names, full address, maybe cell phone, maybe passport numbers, and so on. So this information should be removed. Okay, so once we remove this information, at least the data size will be minimized, and instead of running like 5 gigabyte, for example, it will be like 4 gigabyte point something. Okay, so we try to minimize the information, and at the same time we are respecting data privacy protection. Okay, so the cozy identifier, so this is where we are trying to apply some data privacy techniques like anonymization or encryption or data minimization, pseudo anonymization, and so on. And the sensitive information, it's any information that we need to get the statistical values. Like, as I mentioned, what is the distribution of people in this area? How many people they are using an HPC? How many people they are with or against navigating to an HPC cloud, and so on. This statistical information. So here, before going and running the simulation, I have to do some pre-processing, including this classification of the information. As a result, what I will get, I will respect the data privacy since I'm using some data sets. In addition to that, I will not overload the HPC by a huge amount of information. Yani the data at the end will be minimized. So, like, this is like an example of data sets, yani like that we all know. So, for example, here we have like different columns, different rows, and the first part will be considered as a direct identifier that needs to be completely removed. Then we have the second part where we have to apply some anonymization, and then we have the sensitive information that we would like to share. Okay, so by removing the first one and anonymization, the second one, we will reduce the amount of the information that will be processed into HPC. And by this way, we will not overload the HPC, and we will like preserve the HPC resources. So other type of information, let's say, for example, you have like a very confidential information that you cannot remove a direct identifier because you would like to process it like it is. Okay, so in this case we can use other type of protection. So we can use encryption. You can use secure the files within the HPC. And for example, I have my own files within the HPC, node, and I will try to secure them. Basic thing, it's using a password and using password. And then, for example, I have to use a backup. Like maybe I can, for a specific information, I can have multiple copies offline or also within the HPC itself. And I can create multiple folders that contain redundant information. This will overload the HPC, yes, but it will also protect my information. So in terms of encryption, so we have to consider encryption from different sides. So first, we have an encryption of the information itself. Like, let's see, I'm using the HPC. I already ran my simulation or my code. So if I don't use it anymore, if it is not processed anymore, so this information, it's remaining there, it's still there. Okay. So in order to protect it, if I couldn't, if I feel like the password it's not enough, so I can just encrypt this information and keep it in the HPC. So by doing this, if anyone or any unauthorized access to HPC storage and they collect this information, they cannot decrypt it because they don't have the key to decrypt it. Okay, so this type of information, we call it data at rest. Why at rest? Because it's not used anymore and it is not transmitted. So the second one, it's the data in transit. Okay, so this is when we are connecting our local devices to the HPC, and once we are like uploading, for example, the code, uploading the information, and we are trying to process the information. So this way of transmitting the information also can be protected by encryption protocols like TLS, Transport Layer Security, that will provide a encrypted network between my local devices and the HPC itself. And if I share any information, I'm sure that this information is encrypted. And if someone would like to intercept the network, or if it's dropped the network or collect information through the network, they cannot do that because it's already an encrypted communication. Then we have another, like a very good type of encryption. Now they use it like some companies, they try to integrate it. Why? For the simple reason, because it allows you to do some operation on the encrypted information. Okay, so means, let's say, for example, I have like a number 10, Okay, so this is my information. So I encrypted and it gave me like 99. Okay, so for me, I would like just to add like a few numbers, like 2 or 3. So I will add like 99 plus 2. So it will give me 101. Okay, then I will collect this 101 in my local laptop and I can decrypt it. And it will give me at the end 10 plus 2, which is 12. Okay, it's like a bit confusing. But this type of encryption means that instead of doing the computation in the clear information, okay, the clear text, I will encrypt my information. I will do the computation. I will recuperate my encrypted information, and then I can decrypt it. So by this way, even those that they are working in HPC, they cannot know what is the information. And this is like sort of tricky solution, because also malicious attackers, they can use the same concept. They can use a malicious code, they can encrypt it, integrate it into HPC. And for us as a HPC administrator or cybersecurity, we will not know this information because it's encrypted, and they can run it, and then they can collect decrypted information and use it. So the last one, it's the key management. Like if we go for the encryption and the decryption process, as a solution to protect information within the HPC and outside of the HPC, so we can use some key management. Okay, so means that every time I'm using the encryption, I can generate like a new key to do the encryption and the decryption. Okay, so instead of getting stuck with one type or one key, for the whole information that I have, I can use for every information different encryption process and different key, and I can just store them and use them in case I would like to go for the decryption. So this is like basically how we can protect information, as I mentioned, within the HPC, if it is stored in the HPC itself, or when it is processed, or when it is shared to be processed in the HPC. So in research and in general, so protecting the information and HPC itself, it's like a common responsibility. It's not like okay, because we have security members or we have HPC administrator, they have to be in charge of everything. And even in security, and for us as our security teams, so we help or we support organizations to protect their assets, but like most vulnerabilities and most threats, they were reported by the user itself. For example, if I did something by mistake, if I wait until the administrator figure out that there is something wrong, it will be too late. So I have to inform them earlier, because I am the one who discovered first that there is a problem. Okay, so here this is like a shared responsibility between users and also between HPC members and so on. So here I'm specifying users and PI specifically in terms of research. And once we have like a research project or we are working in a research center, so sometimes once we would like to go and use the HPC, they can provide like for the project itself, they allocate like a node or a HPC node. Okay, so in that project means that all the team members, they have to use the same node in order to run their simulations, or for example to do their own research, which is a good thing. Why? Because the distribution of the storage or the HPC node, it's done based on the project but not based on the user. By doing this, we are minimizing the number of the users. We are also minimizing the number of distributed nodes, and also it will be easy for us to monitor or control if there is any maliciousness within that specific node. Okay, so here first, before starting with this allocation of HPCs, we have to specify what are the information that can be run within the HPC and what are the information that they are forbidden. Okay, why? Because all the organizations, they have to follow some certain government policies or laws, regulations, and so on. And we cannot, for example, use our resources to do or run any type of information. The type of the information should be specified by the organization itself or the institution itself. Okay, so then there is a responsibility of the principal investigators or the manager of the project. So they have to specify, or they have to be in charge to know what type of simulation, for example, their team members they are running, what type of the information they are using, what is the purpose of run the simulation, and so on. So they have to be involved in the security of this HPC. From the user side, also they have to be responsible to to specify the type of the information that they will use it. They need to protect it once they are transmitting the information, once they are doing the processing, and also once they are storing this information. So they have to integrate or to be aware about protection of their information. So the last thing that we have to do, okay, so as we mentioned, so we have the technical side, we have the information side, we already see the user side, but we have to have some security regulations from the organization side. This is what we call the compliance requirements, okay? So generally, this type of compliance, they are like, in addition to the existing government laws, so they are providing some regulations, especially in the collect of the information, process of the information, and share of the information. And some of them, they are protecting type, healthcare information specifically, especially for healthcare research centers. So, which is the HIPAA. For example, for the ISO and NIC, it's more about the information security. And also the GDR, it's a European compliance that's what you call it, like I forget it. This GDR, so it's focused mainly on the organization. They push the organization to respect certain privacy requirements, including the collect of the information and how they process it, and they have explicitly to get the consent of the user. So here, if we have the HPC in general, it's not because this is the hardware that helps us to do some processing, we can misuse it, okay? So we need to protect the hardware parts. We have to protect the information, as I mentioned, and also we have to educate the users. Before they use it, they have to be aware about the risk of mishandling HPC resources or integrating some malicious information and so on. Okay, thank you so much. I think I'm done till here.
Okay, thank you very much, Dr. Almazzi, for this nice talk. So maybe, I have a couple of questions before letting the attendees ask their questions. So my first question is about so in your presentation you talked about the segmentation. So and I think so we have two. So if I'm not wrong, we have two kind of segmentation. So we have the network segmentation and the data segmentation, right? And my question is technically how we can do that. So is there any like tools that help us to do that, or we need to do it like hard do it or something like that?
Okay, so I think I'm just looking for yes.
I think you have talked. You have slide when you.
Yes. Yes, so this is like a case of, as I mentioned, malware. And so here the network, sometimes the term network itself, we took it all the time like a Wi-Fi network, internet network, and so on. But network and the basic concept, it's like a set of let's see, I will take it in terms of devices, like a set of devices that they are connected to each other. Okay, so they are constituting a network. So this is the same thing as I mentioned. Like, let's see, for example, for the case of let's say, for example, we are like an academic institute, and we have a lot of research center. Okay, so means that for every research center, I will allocate a specific cluster from the HPC itself. Okay, so for example, if center one they access to, for example, cluster one, center two they cannot. Okay, so if something happened in cluster one, it will not affect the other because they have different purposes, they have different users, and also different information. So this is what we mean by creating like a network segmentation, means creating a different clusters that they have their own access and also their own users and they don't interconnect with each other. Okay, like someone from cluster 1 cannot connect with cluster 2 and so on. So if something happen, it will be like just within that cluster, but it will not spread to the other and affect the others. So in terms of security, we
Okay.
call it sometimes separation of duties. Like for every specific, let's see, department, so they have their own specific network for the others, but there is no interconnection. So we have to interrupt the interconnection between the two entities.
Okay, thank you very much. It's more clear now. My second question is, so I am part of like team managing HPC supercomputer at UM6P, and my question is, as administrators, how can we control the user's data? Is there any way to do that? So because we don't have direct access. We are not allowed to access to the user's data. So like how
Yes.
we can control without
Yeah,
access?
I will give you my experience with HPC since I was like a researcher. So before creating the account, so يعني as a policy, so the administrator should verify first what is the type of programming language that we are using. For example, if there is any algorithm, what is the type of information, if this is open source information or not, and so on. The information will be verified before creating the account for the user. This is the only policy, because if you create the account and you give them the access, as you mentioned, you cannot control the information once it is processed, but you can control before. Okay, and this is what I mean by we should not just rely on technical solution, but we have to go with policies and regulation, and this should be a part of the institution. Yani anyone would like to use HPC, yes, they can use it, but they should go with the process of verification. So we have to know what is the information, what is the purpose, and a lot of information, then we can provide them access to HPC or not. Okay. Also, for example, I'm given the type of academic institute, since I'm working as a faculty member. So, for example, for let's say for undergrad or students that they are not familiar with the concepts of HPC and how to use it and so on, they have to be under a monitor, which is the faculty member. Okay, so we cannot provide it to anyone. So here you have to use also the access controls, like airbag specifically, which is role-based access control. Like based on the role of the user, you can provide some access, but limited one. A beginner one, it's not like an expert one, and so on. More the person have like a higher position or like need to access to more resources, you can provide more privilege. More, this is not the case, you have to reduce the privilege, and this is how you can control it. But in terms of information, it should be verified before. What is the type of the information and so on. And as I mentioned, because sometimes some people, they are hiding behind like confidential information. Okay, so that's why I provided the strategy of like removing a direct identifier and so on, and keep only the information that really need to be processed in HPC, and not any information you just get it like it is and integrate it into HPC. You get?
Okay.
Mhm.
Yes, of course. Thank you very much. So my last question is, so okay, as a user, so yeah, you talked about like encryption and yeah, some data security strategies, but for example, as user, for example, I have some data and or like for example, I developed the algorithms for machine learning, and then I need to test in some maybe for example some data. But if I like remove some columns, for example, for except the ID, okay. Do you think that the algorithm, like the machine learning algorithm, can, for example, be trained in this like different data at the end because it's different? So how we can manage that?
You mean that you have already just to see if
So we have
I
some
put
data.
okay.
If we remove some columns, the data will be totally changed.
No, it will not be changed because so for example in machine learning, so why we are processing information, because we need like to get a specific results. Okay, prediction, detection, classification, whatever. So here, information that I mean that it should be removed, they should not be even processed with machine learning. Like for example, if I have name, يعني for example, let's see, Omar, Ahmed, Mariam, whatever. So this information itself, it will not give me any additional results. You get, for example, passport number. So here, yeah, just to clarify this, because sometimes, especially for example in healthcare, medical centers, or some information that is collected directly from the user, sometimes we collect their names, their credential information, like names, passport numbers, ID numbers, and so on. This information should not be processed at all in the machine learning algorithm and so on, because the AI solution that I would like to provide should give me like should be trained to get a specific purpose. Like I would like to detect something, predict something, and so on. This information is just additional information. It will not like degrade the results of your machine learning and so on. It should not be at all processed from the beginning. And if you can go, for example, for the public information, you can see, instead of name, you can see the ID, like 1, 2, 3, 4, just the rank, and there is other features. So here, this information, you don't need it. Why you have to remove it? Because you cannot, maybe by mistake you share it with someone else and someone complain. They have right to complain because it contains their real names, or for example, their real IDs and so on. This should be removed from a data set in general. And the other features, like for example, age, gender, position, profession, and so on, this can be processed, but it will not affect, because in the machine learning, you are the one who specify how many features should be processed or not, what are the features that can be included or not, and so on. Somehow you are the one who is monitoring the information.
Okay, yeah, I get it. Okay,
I
so
think there is a question.
yes, Dr. Hanan said, which of the three encryption options you highly recommend? Data at rest, data in transits, or homomorphic?
All of them, they have to be used, but they can be used in specific situation. Okay, like in general, for example, once I'm asking, for example, my students how we can protect information, they see encryption. Okay, but encryption, it's not a practical way in all cases. Okay, so for example, I will split the information into three categories. So we have information, as I mentioned, at rest, in transit, and in process. Okay, so at rest, what do you mean data at rest? That it's the information that I'm not currently using. Like I already developed some research projects or solution. I close my laptop, so means this information, it's at rest. I don't use it. Okay, it's just within a specific file. So in this case, we have a set of way how we can protect it. We can use encryption, we can use the password, we can use the backups, we can archive it, we can use cloud storage, we can, for example, use external hard drive, USB, and so on. You get? Why? Because this information, it's not currently used and it is not transmitted through the network. I have a set of way how to protect it. Data in transit, it's the information that I'm sharing. For example, I'm uploading a file, I'm downloading a file, I'm sending a message, I'm sending an email, and so on. So here, I'm not encrypting the information, but I'm encrypting the communication, the network. And let's say, for example, for the case of the WhatsApp, you can see that it's end-to-end encryption. So means it's not encrypt your information itself, but the communication between you and the others, it's encryption. The network, it's protected. So data in process, in this case, we cannot use encryption. And what do you mean by data in process? It's the information that I'm currently processing, like I'm editing a file, I'm texting, I'm writing a message, or for example, I'm developing or writing a script, code, and so on. So this type of information, how we can protect it? For simple reason, we just need to save it. Because if you didn't save, it will be lost. Or for example, in terms of code, you have to compile or run. Because if you didn't run it or compile it, it will be lost. Okay? So here, it depends on the state of the information. You choose which type of security solution. Encryption, it's optimal for data at rest or data in transit to protect the network. Homomorphic encryption, it's something else. It's that I have information. Okay, let's see, for example, I already have one of the papers. We did it with one of my students. We did it on the salary. Okay, so means, let's see, for example, I have a data set that that includes salary of my employees. Okay, I would like the distribution of salary, it's not equal. Yani not all the employees they are paid the same amount. Yani if I share this information, maybe I can create problem in my organization. Okay, so what we did, I sent this information to let's see to the HR to, for example, add them 10% as a benefit. Okay, but I will not share the real information. I will encrypt it. Okay, so HR, what they will get? They will not get the real salary. They will get only the encrypted one. They will add the 10% and return it back to me. So once I receive it, then I can decrypt and see how much the HR add. Yani for me, I know what is my original information and what is the added value. For the HR, they don't know anything. They just get the encrypted information, they add something, and they return it back. Okay, so this way it's good. Yani once you would like to protect 100% your information, in addition, you would like to process this information. This is the situation where homomorphic it's an optimal solution. Like as I mentioned in the HPC, and for example, let's say for example you already verified the this. That's why I say this is like a tricky part. Like let's say for example you already verify information and you say okay, I will create you an account, you can run it into HPC and so on. So what I will do, I will take this information, I will add some maliciousness, I will encrypt it, I will upload it to the HPC and do some computation. Okay, for you as an administrator, you will see just the encrypted information. Okay, but for me, I already integrated some malicious code. So once I get it, I can just decrypt it and use it for other purposes. And you will not know anything because you don't have the key to decrypt. So this is like here, yani once we would like to choose the mitigation strategy or the control, security controls, we have to see what is the optimal situation where I can choose this control, but not the other one. Yes.
Okay, so lady said, or maybe we can anonymize personal data in case we want to use them in our machine learning model.
Yes. So yes, the anonymization, as I mentioned, it's a part of the protection of the information. I think we did it in this slide. Yes. Yeah, anonymization. So this one, and so what is anonymization? And when we can apply it? Anonymization, we have to apply it when we don't have the consent of the user. Okay. So let's say, for example, for us, we navigate in a specific website, and how the website take our consent. You see that small message like collecting, accepting all the cookies, rejecting all, rejection necessary. You know that message. Okay. So once you accept, you provided your consent. Okay. If you reject, you will not access to the website. So sometimes there is other shop, clothes stores and so on. They are collecting our information, like the historical purchases, what are the items that we like, and so on. And they don't have our consent. I don't give them authorization to use my information, but they want to use it. They would like to sell it to a third party. So in this case, they have to apply anonymization. And anonymization means that I have to remove any unique identifier. Okay, any information that if I read it, I can know who is this person. This is anonymization. It's removing completely the identity of the users. So this is a good technique, so we can use it if anyone, for example, collects also or seal the information, or we have data breach or unauthorized access, so they cannot know real identity of the users.
Okay,
Yes.
thank you, Dr. So Safa said, do you recommend cloud providers for HPC in terms of security, or is it better if the data and processing are done on premises?
So some cloud providers, they are providing some security features, okay? But the problem here between cloud-based and hardware-based, it's like having the control over the whole HPC. So if it is cloud-based, it will be like a part between the organization itself and the third party, the HPC, the cloud providers. So they have also some privilege, okay? So sometimes it's a good practice that help us, like give us like more storage. As I mentioned, it's like less expensive than the hardware and so on. But in terms of access to the information, it will be shared from between the organization itself and the third party. So here it's up to the organization. If they are fine with this process, it will not like create any privacy issue between the server provider and the company, they can go for that. It's a good option. But if the organization would like to have the control over their own HPCs, the hardware remain the optimal solution. So here it's depend. It's depend on the organization itself. But in terms of as I mentioned, maintenance and so on, so the cloud provide also their own benefits, but also they have a problem which is related to cloud in general or centralized platform. It's the single failure. If something happened to the cloud, it will affect the others. So this is another problem. But in terms of security, as I mentioned, so we have only the problem of privacy. If the organizations are fine with that or not.
Okay. I don't know if there is other questions from the attendees. So otherwise, we thank you again, Dr. Almazi, for your nice presentation, answering the questions. So
Thank you so much for the
happy to
invitation, and
yeah,
it's a pleasure to
yeah.
be a part of Morocco HPC. So and looking for other inshallah future webinars.
Inshallah, inshallah. The honor is our. Okay. So I think we are done. So thank you again, and see you,
Inshallah.
inshallah,
Thank
next
you
time.
so much.
Yeah.
Thank you.
Assalamu alaikum.